Okay, so what we're going to be looking at is the whole topic we're doing is linear, which means linear means it's a straight line. So we might see a straight line going that way, or something like that. So we are having a look at things. The next thing we're going to be looking at is graphs of linear. So really what we do is we're looking in a real life aspect, we could be looking at a grid. And this is called the Sydney Ways. In Melbourne, we call it the Mel Ways. They don't really use it too much anymore because of all your GPS on your phones and things like that. But there used to be a book where you had to go and look up if you wanted to find how to get there. But these references are still sort of used with your GPS and locating things. So the same sort of concept works even like on your Snapchat maps. So if we had a look, and you guys are going to be looking at reading off these grids and things like that. So if I had a look at, I'm looking here on the map that there's the TAFE in New South Wales, Northern Sydney. So I might be going, all right, I want to get there. So how would I explain that to someone who's looking at this map? So what they often do is they refer it to by the letter. So you can see that it's in line with the letter P. And then they do the number. So we might say the number 3, so P3. So if they were giving a reference for this in the Sidway, if you said, I'll look it up in the Sidway, they'll say go to page 214, and they'll say P3 is where you can find it, so that you would find it like that. So if we were looking at, let's look at another one. If we're looking, say, at this, I don't know, we want to get to this barbecue area over down here, we would say that it is in L3, or maybe L3 for that one. And so then someone could look it up and work out how to get there. All right, so the consolidate, you're going to be looking at maps and following grids and pretty much looking at trying to find a coordinate. This is like a coordinate in the end of how we're getting somewhere. We're giving a number along this way, a letter along that way, and a number. So we're giving it, this becomes a coordinate. Okay, so that's what the consolidate boys will be looking at when you do that. All right, now we're moving on to the build. So with build, as I said, we're going to be looking at linear patterns. And today we're going to be drawing the graph or plotting the points on the graph. So when you see here, we've got a set of axes here drawn up. So these things here, these lines here are called axes, the axis. Okay. Now the one going from vertical is the Y. So we call that positive Y. So these would be, say, if we had numbers, I could say this is 1, 2, 3, 4. Now, this line here is 0, so that I can have negative numbers, -1, -2, -3, -4. So we often label down there as the negative Y. So that becomes the Y axis. And now this one is the X axis. So we call this one, if we went along, we might say that's 1, here's 2, 3, and 4. Okay, and then you also have negative numbers, -1, -2, and so on, -3, and so this becomes negative X. Okay, so what you're going to be doing originally is you're going to plot these points. So I'm going to do this one with you. So when you get this combination here, often, so that combination, so we're saying when X is -2, Y is 1. So if I went and did that over here on the graph, I go to X is -2, which is here, and I go to Y is 1. So Y is 1 there. So there's that point of -2, 1. So this is called a coordinate. Okay, so when they give you a set of points to put, like a set of numbers to put on the graph, that's called a coordinate. And if you notice, you need to notice that X is given first. Okay, so they always, when they give you a set of coordinates, X is given first. So if we go and plot the rest of these coordinates, so we've got x is -1, y is 2, so I've got there, and then I've got when x is 0, y is 3, when x is 1, y is 4, and sorry, when x is 2, y is 5. So I'll go up there. Now if you notice, what we're going to notice, these set of coordinates are linear. Why? Because when we draw if we draw a line through them all, you can see that it's a straight line. Okay, so that is a linear line. So today will be practicing drawing coordinates. So remember, all these are sets of coordinates onto your axes. Now this whole set, when you draw like a whole graph like this, say this whole thing, that is called the Cartesian plane. So the graph or the grid is called the Cartesian plane. All right, so today you boys will be looking at that, and they will probably all be straight lines because they're linear. All right. Okay, so we're going to look at the equation of a straight line. So we've just talked about before that we have these Cartesian planes. So we've got the x and y axes. And if we find a point, say up here, and if it will have an x and a y value, so that's how we find that, and that's called a coordinate. Okay, so and we've noticed now if we plot a few coordinates, we can get them all in a straight line. And what happens is that you're going to find when you form a straight line, when your coordinates all form a straight line, they probably have, no, they do, they have a formula that follows this type of pattern. So what you're going to see is you might see that, you might see a rule that says y equals, 3x plus 3 or something like that, okay? So that will be the formula that they use to get the straight line, to draw up the straight line. So say, for example, if here you've said that when x is 0, we know that we can see that y equals 3. So if I put that into my formula, x equals 0, can you see that I get y equals 3? So that's how we're saying this, you'll end up with a formula that follows this pattern. So all these straight lines are going to have a formula that looks something like this. So I'll write down a few examples to show you. So for example, you could have y equals -2x plus 2, or y equals x plus 5, or y equals 7x minus 10, and things like that. So can you see that they're following this? There's y equals, there's always this number in front of x, and then another number. So can you see that? Like this m, there's always this, there's always a number in front of the x. And when there's none, there's like a 1 there, All right, so that number there, so there's always a number there, and then we see there's always another number in this C spot. Okay, so when it's a straight line, the rule will look something like this. And the m is the gradient. So I'm going to write that up here. So m equals the gradient. We call that, it'll be a number, and we call it the gradient. So does anyone know what gradient is? What does that mean? Yeah, really good. It's the steepness of the line. So if you look down here, say if we were drawing this line here, it would be 7, it'd be steep, and this one with a 1 wouldn't be as steep, so it doesn't go up as quick. All right, so that's good. Yeah, so the gradient is good. You might write underneath up here, it's the steepness, or sometimes you might hear the word, they call it the slope. Yeah, so they'll talk about the slope of the graph. All right, so we've got the gradient. Yeah? Yes? All right, so we're going to have a look at the gradient. So the gradient is, we might call it the slope. And we often can find it by saying, if we're trying to find the number, looking at the graph, we can say rise over run. So there's one formula that you can use, or we can use this other formula, which I'm going to write down, y2 minus y1 and x2 minus x1. So what we have there is, if I look up here, I'm going to draw on this graph, and I'm just going to count that these are ones, 1, 2, or maybe 3, 4. I'm going to say that is 0, so the x is 0, but I'm going to say the y is 4. Okay, and then I might find this coordinate 2. So I'm going to count along, and I'm going to say 1, 2, 3, 4, 5, 6, 7. So its x value is 7. And what are we up to? 4, 5, 6, 7, 8, 9, 10. And I'm going to say its y value up here. So those two black dots I've found are on the line. So can you see I've really got an x value and a y value and an x value and a y value, and I've got 2 points. So what we can do is we can pretend I'm going to call this bottom one down here, I'm going to call it point 1. So I call it x1 and y1. And up here I'm going to call the second one point 2, so I'll call it x2 and y2. So if I was going to go find the gradient of that one, I'm going to use this formula first. I'm going to show you how to do it with that one. So my y2 is a number 10, and my my y1 is a number 4. So I'm just putting it into the formula, and my x2 is 7, and my x1 is 0, so I'll put 0. So then you can just do that. So 10 minus 4 is 6, and 7 minus 0 is 7. So I know if I was writing this equation out, it would be y equals 6 over 7x, and then I'd have to find this plus c. So I still got to find what this is, but I know the gradient is 6 over 7. It can be a fraction. Now, if you want to use the rise and run method, so if we're going to use this method here, what you do is you start at 1 point, so I'm at 1 point, and you see you rise or you go up or down to get to another point on the line. So if you have a look, I'm at 4, I rise up, and I'm going a rise from 4 up to 10. So can you see I've gone a rise of 6, and I've gone in the positive direction of y. So I say positive 6. So if I was doing rise over run, I'd say m equals a rise of 6. And then the run, you go across until you get to the point. And now I was at 0 and I've gone to the 7. So you can see I've gone a run of 7. And I went in the positive direction of x, so it's a positive 7. Okay, so that ends up being how you can do the gradient like that. Okay, so that's what you can do to find the gradient. So both these cases on here, so both my gradients here, even on this other example, they're a positive gradient. I just might so if I go back here, all right, and some other things that we need to probably take note of on the graph is these points over here are going to be important. Where it crosses the x-axis, it's called the x-intercept. Where it crosses the y-axis, it's called the y-intercept. Now, if you look here at this point here, when you cross the y-intercept, x is always 0. Because if you look, you're going down the x-axis and it's always 0. Okay, so, and then the y value will be wherever it's crossing. So say if I go 1, 2, 3, 4, 5, 6, this one's crossing at -6. So you might say at the y-intercept, you need to remember that x is equal to 0, always 0. And then if you look up here at the x-intercept, we've got the opposite. The y is always 0. So this point here, we'll see something, comma 0. So if I count along 1, 2, 3, 4, 5, I might say this one's a 5, 0. So then you could use these 2 points if you wanted to, and we could get the gradient. I might call that y1 and x1 and x2 and y2, and I could use this formula to find the gradient. This page for a sec. So a positive gradient, so I just want to show you so you know. So if you've got a positive number in that m spot, so the positive gradient, so I'm just going to quickly draw up a set of axes. Okay, so a positive gradient, you will see, a line goes positive up like that. So this is a positive, the gradient is positive. So the number you can see. If it goes down that way, so if you're going left to right, this is the gradient, it's a negative gradient. So you'll see the number in front of the x, or the m value will be a negative number. Just wanted to do